In this content, we'll talk about the measure of central tendency that represents the center, and that is mode. You'll recall from our last lecture that we have three measures of central tendency in terms of. So here's the mode. It's just the number that shows up the most. 9 shows up more often than other numbers in this data set, so the mode is 9. Here in this histogram, we can see that the mode is 4. It represents the tallest bar. And that represents these data right here are shown in this. And you can see that the number that shows up the most frequency when we look at our list is indeed the 4. So the 4 is the mode. So if we were going to find the mode of the number of dreams these students had over the course of a week, we could do it by creating a graph. We could draw the x-axis and write the minimum to the maximum here. It looks like 1 is the minimum and 9 is the maximum, so we could go 1, 2, 3, 4, 5, 6, 7, 8, 9. We could tally all these up. There's a 7, 8, 8, 7, 3, 1, 6, 9, 3, and 8. And in this distribution, we would see that the mode equals 8. So mode, the category or value with the highest frequency or percentage in the distribution. Of all the measures of central tendency, the mode is the easiest one to identify. You just locate the category represented by the highest frequency in the distribution. The mode is not necessarily the category with a majority, like it might not have more than half of the cases. It's just the category in which the largest number or proportion of cases fall. So one thing to remember is that the mode is the best measure of central tendency if you have nominal variables or variables that list categories instead of continuous variables. So also remember, the mode is a value, not a frequency. So for example, here's a graph showing the 10 most common foreign languages spoken in the United States between 2009 and 2013. And you can see they're arranged in order from greatest to least. So if you were going to ask what is the mode of this data set, you would not say the mode is 37,488,624. That is the frequency. What you would say is the mode is Spanish. That's the value rather than the frequency. In some distributions, there are two scores or categories with the highest frequency. You can see in this distribution that we actually have two peaks. And so in this case, we describe the situation as bimodal. We can say that one mode is 74, and the second mode is around 88. You can see that they aren't exactly identical. This one appears to be around 10 in terms of frequency, and this one appears to be maybe around 9. But we still report that it has two modes because we see two peaks in the distribution. It's essentially bimodal. In these situations, we report the two variables with the highest frequency categories. Note also that the average of this distribution is 81. And if you were going to tell someone what's going on in these classes and you just told them the average was 81, it wouldn't really represent the actual scores very well. We have another example here. This figure shows the number of years of marriage before divorce among divorced people in the United States. And you can see, looking at the x-axis, that there appear to be two modes, one around 7 years and one around 21 years. So again, you can see that these two peaks are not exactly the same size. So we have this peak and this peak. So we have the two modes, but they're not exactly the same in terms of frequency. So figure 2 shows that most people who get divorced are likely to have this occur around 7 years of marriage and again around 21 years of marriage. We might say this makes sense because during these middle years, the children, if they have children, they're going to be in school, the parents are going to be very busy, and it might be that around 21 years, the kids are teenagers, it's kind of a stressful time in the home, and that might prompt more people to get divorced. So these two modes make sense. If we calculate the average, you would find that the average number of years before divorce for people who get divorced is 14. We'll write M, or mean, equals 14. We can see again here that in a bimodal distribution, the mean does not very accurately represent what's going on. We can try one more example. The stress ratings of 10 students in the first week of statistics class were as follows: 8, 7, 4, 10, 8, 6, 8, 9, 1, 2. Determine the mode. We could do another graph or frequency table just as we did before, but we could also probably just look at these data. To me, I see that here's an 8, here's an 8, here's an 8. I don't see a lot more 7, 4, 10, 6, 9, 1, 2. I know that once again, the mode equals 8.